Welcome to Study Loop.
This is problem 112 of chapter 7.4 of vector mechanics for engineers, statics, and dynamics. So in this problem, there's a cable stretching from A to B that has a length of 90 meters. And there is a cable from B to C, which has a length of 60 meters. So we're going to go ahead and label the side to the left as cable number 1 and the side to the right as cable number 2. Cable number 2 has a sag of 3 meters, and cable number 1 has a sag of h. And our task for this problem for part A is to find h, and for part B is to find the maximum tension of each cable. And also the mass per unit length for the cables is 0.4 kilograms per meter. So what we're going to start off with is determining the weight per unit length, which would be the mass per unit length times gravity, which is 0.4 times 9.81. And this is 3.924 Newton per meter. So we're going to go ahead and start off with drawing the free body diagram for 1 and 2. So the free body diagram, it's only for half the cable. And we're going to start off with cable number 1 and do the sum of moments around B, set that equal to 0. So this will equal the weight per unit length times 45 and times half the length of the cable, or a quarter of length of the cable, which is 2.5. And then we're going to subtract the tension 0.1 times the h, because that is the vertical distance from here to B in the vertical direction. All right, so we're going to go ahead and simplify. This is 3,973.05 equals T01 times h. And we're going to go ahead and solve for h, which equals 3,973.05 over TZ01. Also, I'm going to put as a side note up here, because there are no external forces other than the forces exerted by the cables, T1 in the x direction and T2 in the x direction are equal to each other, and T01 equals T02, which just will equal T. Okay, so now we are going to do the sum of moments around B in cable 2. And this will equal T02 times 3, because there's 3 meters in the vertical direction between B and 2. And we're going to subtract the weight per unit length times the length, half the length of the cable, times 15, which is a quarter of the length of the cable, which is the horizontal direction, and set that equal to 0. We're going to simplify. So this will equal 3T02 equals 1,765.8. So T02 will equal 588.6 newtons. And from these equations, the side notes we had up at the very top up here, T02 equals T01, so we can go ahead and plug this into here and solve for h, which equals 6.75 meters. And this is the solution for part A, the sag of cable, the first cable. Now we're going to solve for the maximum tension in both the cables. We're going to start off with doing the sum of the forces in the x direction for cable 1. This would equal T1x minus T, which is just T01 and T02. I'm just going to call this T. So T1x equals, we know that T equals 588.6 newtons. Now we're going to do the sum of forces in the y direction and set that equal to 0. And this equals Ty1y minus the weight per unit length times 45. So Ty1 equals 176.58 newtons. So we can go ahead and solve T max for the first cable, which is the square root of T1x squared plus T1y squared. And this equals 614.5 newtons. So that again is the maximum tension for the first cable. And now we're going to solve for the maximum tension in the second cable. So we're going to do the sum of forces in the x direction again. And this will equal T2y. This will actually equal the same thing as the first one, because remember T2x is the same as T1x. So this will be the same thing as for the first cable, 588.6 newtons. The sum of forces in y equal to 0. This equals T2y minus the weight per unit length times 30, which is half of the total length in this cable. So T2y is 117.72 newtons. So now we're going to solve for the max tension in cable 2, which is the square root of T2x squared plus T2y squared, which equals 600 newtons. And this is the last part of B.